Object detection and image recognition. This is something that you will definitely want to do if you have an image that you want to see what's inside the image. Not only what is in the image, like a person or an animal, you'll be able to see where they are in the photograph. So say, for example, you've got a camera that's pointed at your yard and you're monitoring for invasive species. You want to be able to track for anything that's not a human. And then if something comes up with several confirmations, you'll say, okay, turn on the sprinklers to shoo away the invasive species. So with object detection, this detects, it's a task of like identifying what is in the image and where it is in the image. So you can see here we've got a person that's outlined that gives us the bounding box, and then we've got some traffic cones. So it goes beyond what we would normally think of image recognition and just goes all the way into as much object detection as possible that's capable. And the output of this object detector is going to be a set of bounding boxes like we saw here, where we've got a person and the traffic cones. Enclosed are the objects along with the labels and the confidence score. So we see 92% certain that is a person. And so guess what? Yeah, it probably is a person if it's at 92%. So we can rely on that information to help us. So say you're looking for, you see any movement in the yard, you want to make sure that it's at 92%. Oh, it's a person, so definitely don't turn on the sprinkler. You might want to target, like maybe it's a dog, for example. It's not your dog, it's in your yard, but you might want to take care of it. So the great part is they make this super duper easy. They give you a whole bunch of pre-trained models that you can choose from, and the larger models are going to be bigger and require more compute power, but will have higher accuracy. Right? So you can choose from that depending on your use case, and then make it really easy. You can easily run a prediction on any image. So say you've got an image here, you just run YOLO detect predict the model, right? The size, right? So nano or extra large. And then you point it at any image. It could be a local image, it could be a URL, it could be anything you want, and then boom, there you go. So if we're really getting into it, we want to create our own pipeline of, say, we've got our camera set up, we'll take snapshots from the frames, we'll detect if anything changed in the frame, then we'll go and say, okay, something changed, then we'll use the object detector, YOLO predict, and then our model, we'll point it at the image on our local file system. Then we'll see, okay, was it just a car driving by? Was it a human that's just walking past? Or is there something else going on? You'll be able to tell using this. You Only Look Once is a popular object detection software that takes images and then finds what's inside the image. Like, is it a person? Are the person walking by? Is it a dog, an animal, a cat? Is there something in the yard? Guess what? YOLO, object detection, is an image recognition software that's built on open source technology, PyTorch. And the great part is it's open source. And so we can easily walk through and see how it works. I'm going to give us a Docker walkthrough. This will be a Docker walkthrough. So the easiest approach, if you want to start doing image recognition for object detection, you can do that immediately with just a few commands. Let's do that really quick. So I'm going to start off by installing the Docker image. Now it's a pretty big one. It's a pretty big Docker image. So be prepared to download a lot of gigabytes. So let's go ahead and copy and paste our first command here, docker pull ultralytics/ultralytics, and then we'll run that. And I've already downloaded it myself because it takes quite a while to download, so be prepared for quite a long download. And that's it. Now you can just run it immediately. So you take it, you run, I set up a local volume mount so that way I can capture all the data that's output from the image to my local host here. And then this is the command. You run predict your model. I have a nano size, and then we're going to use the beta example, which is, or not the beta example, the tutorial example, the bus.jpg file, which is really nice and easy. So you just copy this line right here, and we'll paste that here in our terminal, and then we'll run it, and it will spin up the Docker container, it'll load the model, and then it will download the image. And once it's done downloading the image, it will run the prediction on the image using the model that you've selected, which is our YOLO v8n.pt. PT stands for PyTorch, right? It's a PyTorch. And so here we go. It's all booted up, runs, loads, downloads a thing, downloading the image, and then it will grab the output. And it even gave us the total performance of it. So it captured the image. Oh, whoa! It says it found 4 people, a bus, a stop sign. That's pretty cool. It ran in about 1 second. It took 1 second on my machine in Docker container running a CPU, right? So it's CPU mode, so it's going to be a little bit slower, as we saw there. But we can see the total time and what it took to deal with it. And then it also saved it into runs, detect, and predict. So we can easily see here that it's in run, ls runs, detect, and predict. And there it is, bus.jpg. So it uses the exact same name. So if we just open that, open bus, here's the image. It's fully annotated. And it shows, we've got people here. It shows the likelihood scores with this 87%, 82%. We've got a bus here, a stop sign. We did it. Wasn't that easy? It took like 2 commands on your computer. And now you have image detection. So if we just do a quick walkthrough of what we just did, we just pulled the container image here from Docker Hub. Then we ran the Docker container and we pointed it at an image. You can also point it at a local image, for example, so you can point it at any source that you're looking for. The easiest to use Python package allows you to embed image detection, essentially object detection in any image. Will tell you what's inside the image and where it is in the image. It's the easiest in the world. It's the YOLO. It's the act. So what is it? YOLO. You only look once. Popular object detection algorithm by Ultralytics, and it uses all open source software like PyTorch. And so here's the installation guide. We need to make sure our system is ready to handle it because you have to install some dependencies like PyTorch, for example. And you can do that by creating a virtual environment, sourcing that virtual environment, and then you install the dependencies, which is Torch, TorchVision, Torch Audio. Depending on your system, you might want version 2.0.1 or a newer version of Torch 2.2.2, which is among the newest versions. For example, I needed to install 2.0.1 on GPU CUDA software on A100s for those NVIDIA CUDA software. For my local system on my Mac that's running Metal, it needed to run Torch 2.2.2 to make that work. So this is the Mac option, and we've got the AWS option. Then you install Ultralytics, and this will install all the rest of the software that's needed for running it. And this is also a pretty beefy installation. It will take maybe a little while to verify that you've got all the right stuff installed. Run pip show torch. And then now you've got this YOLO command that you can run predict on a model that's locally available to your system. The example is YOLO v8in, which is nano.pytorch.pt file. And then you point it at any sort of image that you want, any image on the internet or any image on your local file system. The source will automatically understand whether it's an image on the internet or if it's pointing to a file on your disk. So I've already installed this on my local system. I'm going to copy and paste the command, and then we will put this into our terminal window. Oh, I forgot to source my environment. The good old Python virtual environment. Yep, got to make sure to ensure that you're set up correctly first, and then I ran the command here. It's running, it downloaded the bus, and it will run the process. And that's it. That's it. I did this without installing any other system or dependencies. This is not Docker. This is running locally on my own system. And I simply just ran this command, YOLO predict model, and then the source file. So as we can see here, it says it saved the results to runs detect predict 2. So I can actually just open that. Open predict 2, and this will open up my Finder. All right, here I've got my Finder open, and then I should be able to see this bus.jpg. And there we go. It opens. So we've got our object detection. It works. We've got people, we've got a bus, we've got a stop sign. So even if you haven't configured it for GPU mode, it'll still work on CPU mode. And you can use this software. It totally worked. I just click the buttons and magic happens. So now you have the ability to use object detection in any image that you have, including videos. You could save frames in the video and then just run it through a pipeline, and then you can see what's in the image, and then you can look for certain tags and send alerts based on what's inside those images. Ooh. So you could create a whole business out of this, right? You could connect a camera and watch, say, like a workstation. Make sure someone is at the workstation and they look busy, and then you can just use this software to ensure that they're in the frame and that they're active, they're moving around. And if they're not, you can say when they're away, and you can just we can track everything now. And it's fully available. If you're looking for a programmatic approach to object detection inside of images, to see if we find people or animals in an image, we can detect that. And we can do that using Python and the Ultralytics Python package. It's really straightforward and simple. Just make sure to follow these installation instructions, install the right version of PyTorch and TorchVision, and then install Ultralytics Python package. Of course, you'll be running your virtual environment. So what we can do is we can just grab this example code here, copy and paste it, and then you know what? We can just start up a terminal here and a REPL. So just type in the word Python. Now your REPL's up and running. From Ultralytics, let's import YOLO. And of course, YOLO stands for you only look once. So I guess we're just looking once, right? So we copy and paste that here to make sure we import our library. Then we paste that into our terminal window here. That will import everything. Then we choose our model. This is the official model, and it will know what to do. You can also point to a dedicated model. Now this is a PyTorch file, right? So we get our model there, and then we can get our results by pointing it at any image, including a URL, and then that will run there. That was pretty fast. I was actually pretty impressed. So we can say print results to see what's inside that. Ooh, look at that. Oh, that's so cool. What? What's going on here? Oh, wow. It found a lot of interesting things, didn't it? Oh, what? There's no way there's a toothbrush in there. There's no way it found a toothbrush. Are you kidding? All right, so it's likely that it found, so it did find, I know it found people, found car, it says it found an airplane, but I don't believe it. I know there's a bus in that image. Okay, here we go. So now we can take this result and we understand what's inside our result object. So we've got boxes, which are going to be bounding boxes for what it found inside the image. A mask for the segmentation of the, so I can't tell you exactly what this mask is for because there's nothing there. I tried it. I'm looking at it right now. It just doesn't show anything. But the good news is boxes are there for interesting key points. I'm actually kind of curious to see what's inside key points here really quick. Apparently nothing. It's empty. What happens if we run result.show? All right, we're going to show. Oh, there it goes. Okay, so it just pops up the image itself. That's pretty neat. So right here in the Python REPL, it gives us full access to be able to inspect what we've captured. And then you can save the result if you needed to. You can save it to another location. So what I would do with this is I would loop through all the result data and understand if there's anything interesting that I'm currently looking for. And if there is, I could save that off to another directory that could be watched by another process that could trigger other kinds of toolchain stuff. So like motion detection, and then we're interested in all the key moments of motion detection in a camera that's watching. So we can save snapshots based on what's inside the image. It's AI, it's taking over. While reviewing various image detection technologies to detect like objects inside of the images, there are a couple of options. We've got Detect on True from Meta, which I very much attempted to install on a variety of machines, and it just fails completely. It seems like they've done a really good job at making this system really powerful. The problem is that it is based on older technology, PyTorch version 1, and older versions of Ubuntu. The Docker doesn't build. It won't install locally, even when following the instructions, and so it's had a lot of challenges with Detectron 2. This way, looking at YOLO, which is the you only look once popular object detection algorithm. It's written and it works on PyTorch 2, which is the newest version of PyTorch. It has a higher accuracy model and a variety of models that you can choose from in terms of like the level of accuracy and size and compute power that you have. So for taking a look, Detect on True is another option that we can use, and it has a lot of capabilities. And it looks really cool because it goes beyond just bounding box. You can see that it really takes care of a lot more. This is pretty interesting. So it even gives like better outlines and stick figures, and there's a lot more to this. Though the challenge is getting it to install is where I spend a lot of time myself just to get it to work, and it didn't. I couldn't do it. I tried different VMs on Amazon, different Docker containers. There's just a ton of challenges there, so that's why I recommend YOLO, because that was a lot easier and simpler. It worked really quick and it was really easy. This came in from a request on a YouTube comment from Ala Kazan. The YouTube comment say, "Hey, can you help me detect on 2? Like I want to teach like computer vision model by Meta. It's really powerful, like we saw, right? So it can do a lot. It's very capable. Though the challenge is it was very difficult to install. So walk through trying to get this to install. Does it work? No. Challenge is in. It might work on Windows, but it's running on a 2018 Ubuntu. And so I did find YOLO, and this does work a lot better. I was very happy with this object detection, and it basically works in two commands, right? Install and run. Easy to go. YOLO. Isn't YOLO like you only live once, but in this case, it's you only look once?